I'm at 7 fucking doing shit. Let me show you I'm up to here. I've come here and I'll show you why. I've come to play with something. I've come to play with David Savoury. Where is he? Where is he? Oh, I've got to find him now. Penis. I've come up, I've been here since yesterday. I've come up to borrow those. They're going to feature in the video. I'm not touching the boxes, but there's something fun in those boxes I'm going to be showing you, which is a bit of test gear I won't normally be able to show in a video because it's quite expensive. So they're coming soon. But today I'm going to show you this. I've wanted to play one of these for a while. This is a micro-ohm meter, and it does mad shit with ohms. Let me show you. This is the micro-ohm meter that's shown our new mate. They make a number of them. This particular one can do 10 amps, right? This might not mean anything yet, but they also do ones that do, I think they do 100 and 200, but the one I've got can crack out 10 amps to do its testing. It's also got 4 wires for testing, which I'm going to cover in a minute. And up here, look, you can pause that and look, there's the resolutions it can handle, which are small numbers. We're going to be dealing with some little tiny numbers. Not like your mum's dildo. They're going to be tiny, not big. I forgot. This could be construed as an ad. Yeah, I've come here of my own accord. I'm not being paid to be here. I've asked them to get this meter out for me so I can do some demonstrations on it. There's no payment change hands, although they sponsor the podcast and they pay me to do that. And they've lent me those meters. There's no reason, no monetary reason for me to be sat here now doing this video, showing you this meter, other than the fact that I'm interested to show you this meter. So, it's technically an ad. There you go. We'll keep Eddie happy. Anyway, back to the electrical stuff. I'm going to borrow one of these in the future and do some other tests with it. But I just want to demonstrate because someone asked me about it. Someone asked me about this kind of tester a while ago, and I was like, get me one out. They're really interesting. So it's a 4-wire tester. You'll see here, there's 2 neutrals and 2 cores on this one and 2 cores on this one. They go to these crocodile clips, which are a bit weird. See these 2 cores coming in there? There's only 1 clip, and that's because within here, look, 1 goes to that side and 1 goes to that side. Just going to explain to you, it's a little bit weirder as well, yeah? You don't need to zero these leads, because this is, I think it's a Wheatstone bridge. No, I'm sure it's a Wheatstone bridge, the principle it works on. And you see, on a normal multimeter, you have to know the leads because there's a measurement between here and here that has to be removed because it's not part of the cabling. With these 4-wire ones, you see between those 2 bits of metal there, it does maths. It does some maths between that cable and that cable, which is effectively that cable and that cable. So it does the maths between these crocodile clips, and then when they're together, let me turn around, the maths is done between these 2 terminals and these 2 terminals, which will in fact these terminals, yeah? And then the measurement that occurs between those 2 points and those 2 points here is worked out by maths as well. So you don't need to zero leads. Let's lob this spanner in and demonstrate. Let's see how many that is. So we'll turn it on, which it is. We'll go down to this. That's the wrong thing. We'll go down to this 4,000 micro-ohms using a 10 amp current, and we'll see what we get. Excuse the glare. Yeah, we'll be there. Let's put it on this spanner. So now I've put this spanner here, look. So effectively what it's going to do is it's going to do some mass between these points and do some mass between these points. Then it's going to do some mass between these points and work out the contact between there on the spanner. So press start. Trying to get the glare out. So the resistance between here and here is 442 micro-ohms. A micro-ohm being a millionth of an ohm. So 440 millionths of an ohm is the result between there. So fucking what would be my answer, yeah? So what? What the fuck do I need to measure these small numbers for? That's just an example of how the meter works with its 4 wires, yeah? Let's show something. I was going to do another experiment with a dirty cable. I'm going to show you what we did this morning. Dave was in here, fucking around with it. We come up with a little experiment here. So I'm going to show you how you can find... This is used for finding errors, loose nuts and bolts. It's used for all sorts, but they use them on buzz bar systems to find loose nuts and bolts. I'm just going to show you what kind of things it can pick up in a little experiment done here. So I'm going to get this bit of buzz bar, and what we're going to do is we're going to measure a solid piece of the buzz bar, and then we're going to measure a piece of the buzz bar with holes in. And we're going to maintain the distance by using this plastic relay so that we can do it twice. Let's do it. It'll make sense when I do it. So what I've done is I've clipped onto a solid piece of the buzz bar, so the mass is happening between here, yeah? And I've put this relay in to make the gap the same. So now I'm going to take the relay out. So now I've got a known distance in here. It's one relay in width. And on the screen, I'm getting about between 4 and 5 millionths of an ohm. So what we want to know is, if I then make this gap here with this, there'll be less cross-section area, so we should see that drop. So it's between 4 and 5, and I would say that's taking up half of the buzz bar. So I reckon there's, out the total width, this being the total width here, I reckon that hole's removing half the buzz bar. So I'd expect to see somewhere like, I don't know, 2.5. It can't go to 2.5, can it? But I'd expect to see it half. Let's see if that's the case. Because I've been chuntering on whilst it's under test, I've been setting the experiment up and not turning it off. It's got too hot, so I have to turn it off for a minute while it cools down. Good. That stops me wrecking my instrument because it does it for me. Let's turn it off for a bit. I'll be back soon. The tester's too hot, like its operator. What a fucking knobhead. Right, we're back now. So we are now over this hole. So the measurement that's happening between here and here, I'm going to put it back in a sec. So we're now over the hole and we're getting 5 micro-ohms, 5 millionths of an ohm resistance across that little gap. So yeah, let's just put it back then. So is that double? It's not quite double, does it? But it's sort of right. So what I'm saying is, and check my maths here, that's 5 micro-ohms because this bit's missing. So when we do it on the solid bit, it should just about half it. So let's put it back and see if that's the case, because I got confused with the too hot bit. So it was 6 here, 5 to 6 here. I've put my same gap in, and it's like 3 and 4. Yeah, I mean, it's fluctuating a little bit, and the gap could be slightly different because the reader might be slightly different. But yeah, it's capable of reading this is the main thing. So it's reading the resistance of the buzz bar between the crocodile clips you get as 4 ohms, 4 millionths of ohm. That's a fucking insane number. That's like getting ohm. Get 1 ohm, which is a small reading anyway, which is probably not even the resolution of your normal multimeter. Probably can't measure very well in 1 ohms, unless it's expensive, and you're chopping that into a million pieces. So they do it with inches, don't they? Imagine getting a 1 inch piece of metal and chopping it into a million pieces, and taking 4 of those pieces and being able to measure that. That's what this meter's doing, which I find incredible. Maybe some people are like, fucking hell, you're boring. But I just find it incredible that it can go to that level. And this is the 10 amp one. The 100 amp one and the 200 amp one will measure in numbers that I can't even fucking begin to comprehend in my mind. I'm sat here in the edit, look, just trying to work out how to justify these numbers. 1 millionth of an ohm. Yeah, 1 millionth of something is something so microscopic it baffles belief. I was going to go outside and do it on the street. I was going to measure out 80 metres and do 1 millionth of that. That didn't really work. I just couldn't get my fucking head around the numbers still. Then I was like, where's the furthest place I've ever been? The furthest place I've ever been is the Falkland Islands. Just Googled it. That's 8,064 miles away. I'm not going to tell you where that's from. I think that's from Bryce Norton or Birmingham to Mount Pleasant, yeah? But either way, it's a good 8,064 miles. So I took 8,064 miles, which is basically the very tip of South America virtually. You're almost in Antarctica. And I divided that by 1 million. And that came out to 0.008604 miles. Which then, when I put it into a length calculator, is 12 metres. So I've just measured on that ohmmeter the equivalent of 12 times 5, 60 metres out of a distance from here to the Falklands. So like half, it's just, that's it, like a distance I could walk out of here to the post box, 60 metres, in relation to me travelling all the way to the Falkland Islands, which I'll put a graphic up here so you can see the crack. It's baffling, isn't it? So here's what I did. I took this credit card. This credit card is 0.8 metres thick. This single credit card is just under 1 millimetre thick. Here's a video of me in the Falklands walking down the world's longest corridor, which is 800 metres long. Watch how long this takes at 1,500 times speed. So that recording you just watched, what I just measured on the ohm meter is the equivalent of 1 credit card's thickness over that walk. And if you're wondering why the light's different, it's because I got the maths wrong. But I suppose the question is, so fucking what? Let's look at a real life application of this. But let's say I work in a factory now, make these assemblies. Let me show you the assembly that I make, and let me show you how we're going to test it with this meter. So in the factory, I get a jig and I put this bit of metal on it, this bit of metal on it, this fuse, and I bolt it together, yeah? Then I put this cable on it, which has been crimped somewhere else, and I put this bolt on it, and then I test between the lug, which I'm on here. You'll see that I'm on the lug, between both. I will check, yeah, I've got both in the jaws, look. And I put this right at the end, yeah, as near as damn as I can get it, yeah? That's now reading 792 micro-ohms. And I go, well, what do I do? I've got nothing to compare to any maths. That's just a number at the minute. But the trick is, this bolt's loose. So let's tighten that bolt up. So now I've nipped this bolt with a spanner, look, and dropped the entire rig on the floor, and it's gone down to, well, I've dropped the rig on the floor now. Let's fucking get it all back again. 1 second, but it's lower, look. The surprise is gone now. It doesn't hurt that the entire thing fell apart then, because I'm now going to repeat the test, which shows the repeatability. It's gone too hot again. Oh my God, honestly, what am I doing here? Cretin. I hope this is coming off like the unscripted nonsense that it is to demonstrate his test, because it's fucking unscripted nonsense. But yeah, I suppose the thing that is fell off now is I've just put the crocodile clips back on it, so I'm effectively doing another test on the same thing. So it went down to about 400. We'll wait for it to cool down a bit and we'll see if that's repeatable. But the general gist is that if you were making 1,000 of these assemblies and you check the nuts were tight to the right tightness, and you did 10 of them and they come out at 450 micro-ohms, once you start getting these assemblies that are outside that range, you start thinking, oh, what's loose, what's come apart, what's different? So although the actual reading itself might not mean anything to you as it is, the fact that it's repeatable and repeatable measurements, when you see one at 700, you go, what's up with that one? Why is it 700? That's 250 more, or effectively 50% more than it was. I think that maths is right. So you start looking into the problem. So if you're putting buzz bars together in a factory, if you're putting buzz bars together in a factory, you'll start to get a feel for what's warm and fuzzy and what makes you feel nice. And then when you get one out of the way, you go, hey, what's wrong with that? Is the nut loose? Is it dirty? Is there something wrong with it? So that's this tester, in one of its many uses, could be used to check pieces of buzz bar. We know that we can see if a hole's been drilled in a piece of buzz bar because the number goes up. Imagine you had a piece of buzz bar that went for a wall and you knew what it was, and then it went down, you'd be like, well, what's happened in the void for it to go down, if that makes sense? And that's what this is letting you do. It's letting you see very, very low resistances, which then tell you something's wrong or could be wrong. Anyway, it's cooled down now. I can stop talking shit. It's right back on the end. Yeah, it's right back on the clip. This has been tightened down just with a spanner. I haven't torqued it properly or anything like that. Go. So it was 700 and something before. Now it's 463 micro-ohms, which we can see, tightening that down has made a difference, yeah? So what I'm going to do something now, just out of interest. It's 463. Just to wrap this up, yeah, I'm going to take it all apart and clean it. I've got some Scotch-Brite, some contact clean down there. I'm going to clean it all up and do the test again, see if we can get it down a little bit more. And I'm going to torque it up to the right torque and see what that gets it down. At 415 volts, this 463 microns might not make a blind bit of difference, but you can imagine at really big voltages, that would start causing problems. And as we know, that bolt wouldn't have lasted long loose. It was very, very loose, but it weren't particularly high. But it was at such a high level that your normal multimeter wouldn't have picked it up. So let me strip this down, clean it, and I'll just come straight back and show you what's going off. But yeah, this level of reading is very, very low, but it's also very, very interesting. And I'm going to show you some more, so I'll just show you some more clamps on that, but it's fucking mad what that's reading, to be honest. Some contact cleaners, some Scotch Brite, which is like a non-very abrasive, non-aggressive clean on a rag, and you can see how tarnished the buzz bar is, look. And down that end it's tarnished. Also, this bit of cable that made it, it's all tarnished, so I'm going to clean both sides of that lug, the nut, the bolt, the washer and the contact point, and I'm going to clean that buzz bar as well. I'm not going to touch the fuse, just going to leave that how it is. Just a little before shot, look, it's quite tarnished and pitted. That's also tarnished and pitted, and the lug's not in the best condition. It's just something I pulled off an old job, so let's clean all that up now. I won't show that on camera because it's fucking boring. You can see that's much shinier and cleaner, so I've cleaned both sides of that buzz bar because that's where the contact's going to be made. I've cleaned the contact here around that nut, and I've cleaned both sides of the lug. You wouldn't eat your dinner off it, like, but it's a lot better. So I'm going to put it back together now, and we'll see what we get. I think we had 4, 6 something now. I'll put it on the screen here, what we had last time, and we'll do the comparison. So clean, right back on the end there. That's been just nipped up with a spanner, sort of the same as it did before, not torqued. We're right on the end there. So we'll just turn it on, wait for it to do its thing, we'll do the test. I don't think it'll make a massive difference, but I think there'll be some difference because it weren't like it was minging. It's copper, it's tinned copper, so I don't know what the difference will be. But I think it was 462 when it'll be on the screen what it was. Oh yeah, so it's made a slight difference, but not a massive amount, but it has made a difference. And I guess if we move this crocodile clip further down here, if I move that down to say there, we should again see a difference. Which we do, it's gone down. So I've moved that far and got down that much. So the cleaning is going to do, it brought it down by a bit. There was definitely, whatever it is, I'll put on the screen here if it's a YouTube video. So yeah, it can see these things. It's particularly good that it's seeing the loose nuts and bolts. That's micro-ohm testing. I've always wanted to play around with one of them. I've played around with it a bit more than I've shown today because I possibly want to take one away and do something with it. But while I'm here, I've just covered the very low figures that can do. And just remember, it's a 4-wire test. So these are on different wires that go back to the meter. One of them's voltage, one of them's current, I think. I'll show you another little interesting probe to show me while I was here. I'll check that out for you. So if you're thinking, what would I do with those big daft crocodile clips on the job I've got it for? Well, they do smaller crocodile clips. I think they do even bigger crocodile clips than that. But they also do these, look. That's a 2-prong lead. And at the end, it's got the 2 prongs. So obviously it does the mass between the prongs and the mass between the prongs. So it does the mass between the prongs on one prong, and then it goes between the 2 prongs like that. So there's all sorts of accessories for it, depending on what you're doing. Chevrolet let me go up here and play with that today. Thank you to them for letting me fuck up their conference room table with loads of contact cleaner. If there's anything you'd like me to micro-ohm, yeah, I'm going to do that. One of the things I'm going to do, I'm not going to do it here today because I haven't got a comparison thing, is this. I was wondering how much, this is one of them, this is the earlier one with the magnet in. I was wondering how good is this compared to a crocodile lead. I haven't got exactly what I want to show in a video, and I've got plenty of other stuff to play with today, so I'm going to do this lead at some point to show... Yeah, sorry, cut off there. I'm going to do this lead at some point, but I need to do this lead with another R1. I need to use another lead that's got 2 crocodiles on the end, that's made out of the same material, that's the same length. And also, I'll tell you a secret, that's what I was meant to be doing with this little rig here, but there's a problem with the rig that means the tests aren't consistent, so I need to adjust that. So yeah, tell me how you do your R1, R2, and do you use one of these magnetic leads? Do you use a double-ended crocodile clip, like your mum uses a double-ender, or do you just take the cable out and link it to the bar? I'm going to do all those options, yeah, but if you think of anything more, I'll be really interested to see the resistance of that on this ohm meter, not amp meter, like I said earlier. Let me know, and what I'll do is I'll borrow one of these off them at some point in the future, and I'll do some of that shit to see how it gets on. There's a bit of a sparky thing I want to show as well, so I'll quickly do that now. It's just recreation something while I was testing. I've just put the crocodile clip back on there, put the crocodile clip back on there. I've put the lug on there and loosened the nut off. Let's crack it onto the 10 amp test. Let's start it. I've turned the lights out because that's now going to pump out 10 amps. When I press this, pump out 10 amps, just out of interest. So it's over 400 microvolts because that connection is crap. Maybe if I push that down a little bit, I'll be able to get it to go lower. I can look, I can just hold it down with my hands, but the crack is this. See if we can get it to spark There it is. Can you hear it? See the ampage? Here it is, look. Woo! I don't know if it's as dangerous or not. Maybe they won't want me showing this, but yeah. There's the amps, the 10 amps that's doing the test. Oh, I've lost it. I'm on hold. I think I fucked the meter up. No. Here we go. I'll just take a bit of this to try and get a good shot of it. There you go. I'm just going to do some more because when I make this into YouTube, this will be B-roll. There you go, look. So I can actually hover that. So there's note there. And get the spark. There it is. So yeah, it's cracking some amps out. That's 10 amps doing that. There we go. There's your 10 amps. And that's what it looks like when it's doing its business. So yeah, that's Chevron's micro-ohmmeter. So yeah, that's Chevron's micro-ohm. That's a CA6240. That is the 10 amp one, which is measuring 1 millionth of an ohm. The 100 amp one and the 200 amp one measure lower than that. They go to ohm, so I don't even want to get into. They go into, instead of going, that micro-ohm is 0.0005 times 1. The ohm ones, I'm getting this wrong, but I'm sure they'll correct me and I'll tell you properly. They go to silly numbers that I don't even want to talk about, because at HV levels, like seriously high voltage levels, that resistance, those millionths of an amp, make a fucking massive difference. I remember being offshore once on a job and a guy had terminated a bit of cable that was 132 kV, and I was looking at it because you can have a look if you want, get a bit close and have a nose at it. And I touched the cable with my finger like that, and he went, I said, look, don't touch, because he says, now I've got to fucking re-clean that cable. So if I put the lug on there, the oil off your skin will fuck that joint up at some point in the future. So that's what matters at this level. And again, cheers for Chevron for letting me fuck up your conference room table and letting me with the gear. I'm going to go back upstairs now and annoy David Sable for the rest of the day. If anyone's got any questions, I'm at Chevron for the next couple of hours. So if anyone's got any actual questions that I've not really covered, I'll get Kev to fucking give me the answers. So if anyone's got anything they want to ask, the box will be next. Dan from DMH, my great internet pal, has asked me to get a fucking length of DC cable and then get another length of DC cable with a fucking MC4 plug-in. Mate, I'm not carrying fucking loads of MC4 plugs and bits of solar cable around my van on a daily basis, so there's not... Oh, hang on. Oh, well, fucking bollocks. I'll do that. So randomly I brought with me, because I brought a load of stuff to possibly fuck around with this tester. My lens is dirty, hang on. That's better. So randomly I bought with me a load of random stuff, and I happened to bring these pre-manufactured Victron solar cables. So I've taken one of these short ones and I've cut it in half and I've plugged it into itself. Let me show you. That's plugged into itself. And then I took one of the longer ones, which is used exactly the same cable, and I've cut the cable to an equal length and stripped the equal length off the end. So these bits of cable are exactly the same, apart from the fact that one's got MC4 in, factory made MC4. So Dan, I will do that for you now. Let me set this up. So I've got the length of non-MC4 cable. I've twisted them together and I've put the clamps on right at the ends, and I've given them a little squeeze. I've given them squeeze as hard as I can. So I've squeezed that as hard as I can. I've squeezed that as hard as I can. So and I've kept them on the table. They're not the same way up. Let me change that 1 second. I've put them in the same place in the same teeth with both the cables the same around, and I've squeezed them as hard as I can so they're consistent. Right, I'll turn it on and we'll do the test. This is a set length of solar cable, and it's got no MC4 in. It's over 4,000 microns, so I'll have to drop down to... Whoa, that's... So it's over 4,000 microns, that's unusual. Right, we'll drop down to the 1 amp 40 milliohm test then. 4.96 milliohms. Right, let's put the MC4 one in. Oh, it's not, yeah, 4.96. Stop. Holding that value. Right, so the last one was 4.96 milliohms. I've now set them up the same look, crocodile clips, same, in the same hole, same length of cable, but with an MC4 in. It's a factory-made Victron one. 5.08. So the difference is whatever it is. I ain't done the maths, but yeah, that's took up to 5.08. Obviously, it won't work on 4,000 microhms. Just check. So yeah, it's not better. So yeah, the MC4 is adding whatever it's adding. I don't know what that number is. That is a brand new MC4 connector. The difference is, I'll have to look back at the video, but I'll do it in a second. That's the difference. So on the set length of cable, with a pre-made Victron plug, made in the factory and kept in a clean plastic bag before I cut it up this morning, I think the difference is 50 micro-ohms, isn't it? So there's 50 micro-ohms resistance. What you've got to remember is if you've got a string, there'd be maybe, say it was 8 panels, that would be at least 20 of those plugs, wouldn't it? 20-ish of those plugs, 18-ish of those plugs. So you've got to take that value and times it by the amount of plugs you've got. What Dan's going to do for me now, see, he's just done that for him, is Dan's going to get me, next time I see him, a variety of MC4 plugs from different manufacturers that are old and new and been on roofs for a certain amount of time. And he's going to give me them, or we're going to meet up and we're going to get these testers and we're going to go and test a load of old, new, different fucking plugs, different manufacturers and all that, see how that affects. But hopefully that's of use to anyone. You can imagine if you had like a 20-string panel, how that would add up. So that resistance would be on a higher voltage, and you could do all the maths for that anyway. But yeah, I hope that answers your question, Dan, because it took me fucking ages to do all that shit. See you later. Fuck off, Dave. What's that you're wearing, Dave?
Why, it's the show by now. New 6A6117.
Oh. Ohm, 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 ohm.